Hello students, this is Mrs. Crumpton. I wanted to clarify some information and some examples from the PowerPoint that you watched in class with a little bit of a video lesson for you. So please take notes and add to the PowerPoint that you had yesterday. Okay, this is one of the examples that was on the PowerPoint.
Are you having a leak?
Okay, now we said when we initially worked this problem that our common difference is that we're increasing by 6. And of course in our term number we're increasing by 1. Okay? This led us to determine that our expression is 6n. And the 6n means that we can find the term for any term number that's requested. For instance, if I ask you the 654th term of this expression, then you would multiply 6 times 654. Okay, let's look just a little bit further, and I'm going to change ink color here. So what we're meaning when we get this expression is 6n. 6 times 1 should give me the term. Again, my expression 6n, 6 times 2 should give me the term for the second term. My expression 6n means that 6 times the term number should give me the term. My expression 6n, that means 6 times the term number, should give me the term. And that works nice and neatly for this particular example. Now let's look at this particular example. Let's find our common difference. Common difference. How much am I increasing by? I hope you said 4. Increasing by 4 each time. My term number, again, I'm increasing by 1. Now this implies that my expression should be 4n. However, if I try that, 4n, 4 times 1, that equals 4. Alright, take a look again. 4n here, 4 times 2, that equals 8. 4n, 4 times 3 equals 12. 4n, 4 times 4, that equals 16. So actually what's happening is my terms each time is increasing. My terms are increasing 4 more than what my expression is implying. That is consistent each time. So instead of our expression being 4n to find the nth term, my expression would be 4n plus, forgot to put a 4 there, 4n plus that difference of 4. Now, if I ask you to find the next 3 terms, according to what we have here, we know that adding 4 we should get 24, 28, and 32. Okay, let's try our expression to see if that actually works for us. So we've got 4 times the 5th number in the sequence. See here I'm gone to the fourth number in the chart. Right here in my chart, I've only gone to the fourth number. So I'm adding the fifth number in the sequence. Okay, now if I've done this correctly, I should get 24. Okay? So 4 times the 5 plus 4. Does that give me 24? It does. So I know that this expression is correct where this one would not be. Okay, let's take a look at another example, and hopefully this will clear it up. And any problem 1 through 16 from page 284 that you were unable to do or that you feel like is wrong, you can go back and make your corrections. Okay, let's find our common difference between the terms. Common difference. Are my numbers increasing? Are my numbers decreasing? My numbers are increasing each time by 5. Okay, this implies that my expression should be 5n. Okay, my common difference again, we didn't look at the common difference in the terms, but of course that is quite obvious. I'm increasing by 1 each time. Okay, so let's test it out. If my expression is correct, when I multiply 5 times the term number, I should get -9. But 5 times 1 is only 5. Okay, so my expression is off from that one. 5 times n is the term number, implies that it should be 10. That is off. 5 times the term number, that's 15. Forgot to put my equal sign here. That is off. 5 times the term number, which here the term number is 4, that's 20. That's off from what my term actually is. 5 times 5, 5 times the term number, would be 25. That is off from 11. Now, how much am I off? And am I off consistently? I'm going to pause the video for a minute while you look at these numbers and see, am I off the consistent or the same amount each time? Okay, if you look at a number line, the difference between 5 and -9 is I am decreasing. I'm decreasing by 14 each time. I'm decreasing here. Look at the number line under the board. I'm decreasing by 14 each time. So this now implies this expression is wrong, and it implies that my expression should be 5n minus 14. Okay, so let's test it. Let's go back to the first term here. And let's replace n with 1. So we've got 5 times 1 minus 14. 5 times 1 is 5 minus 14. Different signs, we subtract these numbers. Ooh, excuse me. That should not be a 19. That should be a 14. My mistake there. 5 minus 14. That should give me negative 9. It does. This checks out. So I know that my correct expression for this arithmetic sequence is 5n minus 14. And you should be able to find any term that I gave you for this arithmetic sequence. Okay, now I want to look specifically at problem number 3 from page 284 because I had gotten some questions about fraction problems. With fraction problems, in order to find your common difference, you're going to have a common denominator. Okay, so find your common denominator. I'm having trouble getting my pen to write. Common denominator. Okay, for this arithmetic sequence, your common denominator is what? What is the least common multiple of the numbers 6, 3, and 2? I hope you said 1/2. I'm sorry. I hope you said 6. So we're going to keep this first term as it is. An equivalent fraction with the denominator 3. I'm going to come over here to the side. 1/3 with a denominator of 6. 3 times 2 gives me 6. 1 times 2 is 2. So my equivalent fraction here would be 2/6. Equivalent fraction here, 3/6. 1/2 is 3/6. I hope you knew that one without me having to do that one for you. 2/3. Common denominator 6. Multiply numerator and denominator by 2. 3 times 2 gives me 6. 2 times 2 gives me 4. So my equivalent fraction would be 4/6. Okay, now that we have a common denominator, look at your numerators. What is the common difference of my numerators? I am increasing by 1. The only thing is, now we've got to think about that denominator. I'm not actually increasing by 1 whole. I am increasing by 1/6 each time. So, and my common difference, of course, in the term numbers is constant with +1. Okay, so this implies that my expression would be 1/6 n, 1/6 n. So let's go back up here and let's test it and let's see if that is going to be my expression. So I should be able to say 1/6 n and get 1/6 in my term. 1/6 times 1 equals 1/6. So this is my correct expression. And from this, you should be able to find the next 3 terms in this arithmetic sequence. Students, hopefully with these extra examples and a little bit extra time, you should understand these problems from page 284 a little bit more clearly. If you were not able to complete this assignment, please do so. If you feel that you need to go back and make corrections, you may also do that. Then we will check the answers, and this assignment is for a grade. Thank you very much, and hope you have a great day. I'll see you back in class.